Welcome to the mathematics lecture series. Today we continue with the Laplace transforms lecture series. Continue with the lecture note of chapter 6. Go to page number 233. So unit step function t shifting. So for unit step function we will define a function u of t minus a, which is called also the Heaviside function. So the unit step function or the Heaviside function u of t minus a is defined as follows: u of t minus a equal to 0 if t less than a, and it is 1 if t is greater than a. So there is a theorem which is called time shifting theorem or shifting theorem. So suppose ft has a Laplace transform which is fs, then we tell the shifted function which is denoted by f tilde t, which is denoting as f of t minus a u of t minus a. So this is defined as equal to, it is 0 if t less than a, because u of t minus a it is equal to 0 if t less than a, so total function will be 0 if t less than a, and we know that if t greater than a, then u of t minus a is 1, so this is f of t minus a if t greater than a. Then the shifted function f of t minus a into u of t minus a has a Laplace transformation of the form e to the power minus as f of s, okay, where L of ft equal to f of s. F of s is the Laplace transform of ft. So we can write it as L of ft minus a u of t minus a equal to e to the power minus as f of s. Okay, so if we take the inverse of both sides, then f of t minus a u of t minus a can be written as L inverse e to the power minus as f of s. So find the Laplace transform of the function t minus 1 u of t minus 1. So we already know by the shifted function theorem that L of f of t minus a u of t minus a equal to e to the power minus as f of s. Consider here f of t minus 1 equal to t minus 1, so we can write f of t equal to t, because if we put t instead of t minus 1, then f of t equal to, we can write it as t. So L of t minus 1 u of t minus 1, we can write it as e to the power minus as L of ft, because fs equal to L of ft, so L of ft. Here a equal to 1, you can see as a equal to 1, so e to the power minus s, and L of t, because ft equal to t, so the Laplace transform of t is 1 by s square, so e to the power minus s by s square. This is the required answer. Continue with the next example. Find the Laplace transform of the function e to the power minus 2t u of t minus 3. So L of e to the power minus 2t u of t minus 3 equal to, we can write e to the power minus 2 t minus 3 e to the power 6, because e to the power 6 e to the power minus 6 will get cancelled, we will receive e to the power minus 2t, and we can write u of t minus 3. So e to the power 6 will get come out, so L of e to the power minus 2 t minus 3 u of t minus 3, so e to the power 6 into e to the power minus 3s by the formula of this e to the power minus 3s L of e to the power minus 2t, here a equal to 3 and ft equal to e to the power minus 2t. So e to the power 6 into e to the power minus 3s, and L of e to the power minus 2t we can write 1 by s plus 2. This is the Laplace transform. So we can write finally e to the power 6 minus 3s by s plus 2. This is the required answer. Continue with the next example. Find the inverse Laplace transform of s e to the power minus 2s by s square plus pi square. So we know that L of f of t minus a u of t minus a equal to e to the power minus as L of ft. So if we take both side L inverse, so L inverse of e to the power minus as L of ft equal to, we can write f of t minus a u of t minus a. So L inverse s by a square plus pi square, we know already that it is cos pi t. So we consider this as ft. Here we consider a equal to 2. So the inverse Laplace transform of this function is equal to inverse Laplace transform of the given function L inverse of s e to the power minus 2s by a square plus pi square. We can write it as L inverse e to the power minus 2s into s by a square plus pi square. So this is of the form this. So we can write it as f of t minus a u of t minus a. Here a equal to 2 and ft equal to cos pi t. So cos pi t minus 2 and u of t minus 2. Because f of t minus a, here a is 2, so cos of pi t minus 2 and u of t minus 2. So this is the required answer. Next we come to the periodic functions and the Laplace transform. So what is periodic function? If a function can be written as f of t plus capital T equal to f of t for all t greater than 0, then capital T is said to be the period and the function ft is said to be the periodic function. The function ft is defined in the interval 0, infinity, that is in positive interval. So the Laplace transform of a periodic function ft is given by this formula L of ft equal to integration 0 to t e to the power minus st ft dt by 1 minus e to the power minus st. So let's come to the example. Let ft be a periodic function which is defined by ft equal to 1 if 0 lesser equal to t less than 1, and it is 0 if 1 lesser equal to 2 less than 2. Then find the Laplace transform of this periodic function. So let's draw a graphical picture. So what is in 0 to 1 the value is 1, so this is like that, and in 1 to 2 the value will be 0. So in 1 to 2 the value is 0. Okay, so this will be repeated as it is a periodic function. So in 2 to 3 again the value is 1, and 3 to 4 the value is 0, and this will go on. Okay, so we know that ft is a function which has a period of 2, that is capital T is 2 here, because 1 between 0 to 1 it is 1 and 1 to 2 it is 0, and this is getting repeated again and again. So between 0 to 2 interval this is one function, it is defined 0 to 2. So the period is 2, so capital T equal to 2. So we can write it as f of t plus 2 equal to f of t. So the Laplace transform of ft is given by this formula. Put capital T equal to 2. Okay, so integration 0 to 2 e to the power minus st ft dt by 1 minus e to the power minus 2s. So 1 by e to the power minus 2s integration 0 to 1 e to the power minus st 1 dt, because between 0 to 1 the ft value is given by 1, and between 1 to 2 it is 0. So the plus is 0, the plus is 0 because ft value is 0 between 1 to 2. So between 0 to 1 it is defined only, and the value is 1. So do the integration and you will get, after final calculation you will receive the value 1 by s into 1 plus e to the power minus s. So this is the required answer. So from today's lecture you can solve the problems from assignment, problem number 49 to 55, then problem 56 and 57, which is inverse Laplace transform, which you can do by using the shifted function theorem. Then find the Laplace transform of the periodic function, problem number 58 to 60, which is a periodic function Laplace transform. Okay, so this is the end of this assignment related to Laplace transformation. So thanks to everyone, wish you all the best.